The supervolcano that ended our last ice age may have also led to the extinction of Neanderthals. It has been responsible for some of the most devastating earthquakes in human history, and its magma chamber is big enough to bury all of Europe under 30 centimeters of ash. Welcome back, everyone. Here today, we are going beyond Yellowstone to uncover two of Europe's secret supervolcanoes. Let's get into it. To understand these volcanoes, we need to rewind about 2 million years ago when Europe was still largely out of bounds for early humans. This was the time when the mighty titan known as Toba roared to life in what is now Indonesia. The eruption ejected an unbelievable 2,800 cubic kilometers of material and was so large that it has been dubbed the King of the Supervolcanoes. In addition to causing the largest climate change event in the past 2 million years, this blast also triggered massive earthquakes across Europe. What could have caused this? Well, giant earthquakes can be triggered by huge landslides and debris flows caused by volcanic eruptions. As an example, in 1980, the eruption of Mount St. Helens in Washington state triggered a giant landslide that generated a magnitude 7 earthquake. And that was a small fry compared to Toba. But the main reason that earthquakes occurred across Europe is because of a phenomenon known as seismic migration. When magma is forcefully ejected from a volcano, the energy released causes the Earth's crust to shake. However, since the crust is a solid and rigid structure, it takes time to adjust to sudden changes in pressure. Therefore, after the initial shaking subsides, there is often a delay followed by even stronger tremors in different locations as the crust migrates to relieve the leftover pressure. So let's fast forward to just 54,000 years ago. As the last ice age was coming to an end, a new volcano erupted in Europe. The culprit was Garrotxa, a volcano located in the northeastern part of Spain, about 100 kilometers north of Barcelona. Now, you might not recognize this place, but believe me, if it had erupted in modern times, it would have been a very big deal. The blast radius would have affected areas up to 500 kilometers away, and most of Catalonia and parts of France, Andorra and the Balearic Islands would have been completely buried in ash. That's right, a layer of ash almost 1 meter thick would have blanketed much of Barcelona. So if you were in the city at the time, it would have looked something like this. This eruption took place during a period known as the last glacial maximum, when ice sheets covered much of Europe and North America. But surprisingly, the ash from this eruption managed to travel all the way to Ireland, where it mixed with other volcanic debris from Iceland to form a layer of sediment known as the GS1 ash bed. Geologists were able to identify this ash bed in various Irish lakes, peat bogs, and the seafloor, and they used a technique called tephrostratigraphy to analyze the chemistry of the particles. They discovered that the majority of the ash came from Garrotxa, and the fact that it traveled so far means that the eruption must have been absolutely massive. Scientists estimate that the total volume of material ejected from the volcano was around 600 cubic kilometers. For perspective, this is roughly equivalent to the entire volume of the famous Mount Vesuvius, which famously destroyed the Roman city of Pompeii. Now, while this eruption was incredibly violent, scientists have estimated that it only had a local impact on temperature and precipitation. In fact, it seems that this eruption did not even cause major disruptions to the environment or climate of Europe. One reason for this is that the volcano erupted close to the end of the Ice Age. By this point, temperatures were already rising, and conditions were becoming more favorable for plant and animal life. Another reason is that the ash cloud produced by the eruption didn't reach the stratosphere, which is the part of the atmosphere that is 10 to 50 kilometers above the Earth's surface. Eruptions that send ash into the stratosphere can block sunlight and lead to global cooling, like what happened during the Toba supereruption. But the lava Garrotxa eruption was too weak to do this. The ash cloud only made it into the troposphere, which is the lowest layer of the atmosphere. As a result, there is little evidence of global or even European climatic effects. Instead, it appears that the eruption only caused local environmental disruption. Pollen records from the nearby Montserrat region show a significant drop in vegetation diversity in the years following the eruption. But within a few decades, things were back to normal. However, the story doesn't end here. You see, despite being dormant for several thousand years, scientists believe that the magma chamber beneath La Garrotxa is still active. In fact, it contains enough magma to produce dozens of eruptions similar in size to the one that occurred 54,000 years ago. There have been some signs of recent activity, such as an increase in the frequency of earthquakes in the region. And in the year 2000, scientists detected a swarm of earthquakes lasting nearly 3 weeks. Although this was not accompanied by any volcanic activity, it was possibly a sign of magma moving underground. So it turns out that this ancient super-eruption in Spain is not an isolated case. There are actually 2 huge magma chambers hidden beneath the Iberian Peninsula. These chambers are located deep in the Earth's mantle, about 150 kilometers beneath the central part of the peninsula. To put this in perspective, the magma chamber is almost as wide as the entire British Isles. But how did this happen? Well, it all comes down to plate tectonics. You see, the Iberian Peninsula is located on the western edge of the Eurasian plate. And as the Americas moved west across the Atlantic Ocean millions of years ago, the plate carrying Iberia collided with the African plate. This collision formed a mountain range known as the Atlas Mountains. But as the plates continued to push against each other, the Iberian Peninsula began to bend and the crust started thinning, creating a weak area known as a lithospheric flexure. Hot magma from the Earth's mantle then began to well up into this weak zone. Over millions of years, this magma accumulated and formed 2 large batholiths, which are giant blobs of igneous rock. One of these batholiths extends southwest from Madrid towards Portugal, while the other one runs roughly parallel along the southern coast of the peninsula. Together, they form a continuous belt of igneous rock that is over 500 kilometers long. In the past, scientists believed that these batholiths were simply the result of magma that had leaked into the weak zone. But recent studies have shown that there may be more to the story. According to a study published in 2022, the majority of the magma came from a deeper source. Using advanced computer models, researchers were able to simulate the forces acting on the Iberian Peninsula. They found that the weight of the African plate caused the lithosphere to bend and thin, allowing hot material from the Earth's mantle to rise up. This material originated in a channel that connected the Atlantic Ocean to the Mediterranean Sea in the distant past. But as the peninsula moved west, the connection was cut off, and the magma became trapped beneath the Eurasian plate. This explains why the magma is enriched in potassium, niobium, and tantalum, which are elements that are typically found in ocean water. To further confirm their theory, the research team analyzed samples from boreholes and mines that had reached deep into the batholith. They discovered that the magma is actually older than the mountain range itself, with some parts dating back as far as 300 million years. This finding suggests that the magma was already present beneath the peninsula when the Atlas Mountains began to form. But what does this mean for the future? Well, it turns out that these magma chambers are the driving force behind some of the most powerful earthquakes in recorded history. In 1755, a massive earthquake struck the region, causing widespread destruction in Lisbon, Portugal. The quake had a magnitude of around 8.5 to 9, making it the most powerful earthquake in Europe since records began. It is estimated that the earthquake and subsequent tsunami killed between 10 and 100,000 people. Scientists believe that this disaster was caused by the sudden release of energy in the magma chambers, which built up pressure in the crust. However, this is not the only earthquake that can be linked to these chambers. In 1428, a powerful quake with a magnitude of around 7.8 struck the same region. Historical accounts say that the ground shook violently for 5 minutes and that buildings were destroyed as far away as Barcelona. And in 1995, a smaller quake with a magnitude of 7.3 hit just off the coast of Portugal. While these events are rare, it is important to note that the Iberian Peninsula is one of the most seismically active regions in Europe. Every year, There are dozens of earthquakes that shake the peninsula, many of which are strong enough to be felt. Now, while it is unlikely that a supervolcano will erupt anytime soon, it is possible that the magma chambers could continue to migrate and trigger powerful earthquakes. If that happens, the damage could be catastrophic. Large cities like Madrid and Barcelona would be at risk, not to mention the historic towns and villages that are scattered throughout the region. Therefore, it is important for residents to be prepared and aware of the potential risks. What do you think? Did you know about these secret supervolcanoes? Do you live in a high-risk area? Leave a comment below and tell us your thoughts. And don't forget to subscribe for more explosive science stories. Thanks for watching. See you next time.